In continuation with the construction procedures of an ellipse, in this particular session, we will see the construction procedure of an ellipse by directrix and focus method. Directrix is nothing but a fixed straight line, while the focus is nothing but a fixed point. So first we will see what is an ellipse. As we know that ellipse is a conic curve which is generated by taking sections of a cone, and that section is inclined to an axis or inclined to the base of a cone. For this particular method, the definition of an ellipse is defined like this, that it is a path traced out by a point which is moving in a plane such a way that ratio of its distance from a fixed point, this fixed point is nothing but a focus, to the distance from a fixed line, that is nothing but a directrix, remains constant and it is less than 1. Okay. So here ratio of the distance of a point with respect to fixed point to the distance from a fixed line, that is directrix, is nothing but an eccentricity, and that eccentricity is less than 1 for an ellipse. So to understand this definition, we will consider a fixed line, that is nothing but the directrix, and consider a fixed point, that is nothing but the focus point F. Now if you consider the portion of an ellipse with respect to directrix and focus point, say this is the portion of an ellipse, right? Then any point on the ellipse, say that point P, in that case the distance of point P from the focus to the distance of point P from the directrix, say the distance from focus is A and distance from directrix is B, then this ratio, that is E by B, should be equal to eccentricity. Consider the eccentricity say 2 by 3, then this ratio should be common for all the points on ellipse. Okay. P1, P2, P3, if you consider any point, okay, say for point 3, the distance from focus will be this, that is A, and the distance from directrix is this distance, that is B. So this ratio should be common for point 3 also, means for all the points on ellipse, that ratio should be E by B, that is nothing but the eccentricity. So the required data for this particular method is the eccentricity, and that should be less than 1. And second data is the distance between directrix and focus. So these two data are required to construct an ellipse using directrix and focus method. Now moving further, we will go through this step-by-step procedure for the construction of an ellipse. So first, draw a fixed line, that is nothing but a directrix. So that line you have to draw, that is nothing but a directrix. On this directrix, take any point O, and from that point draw an axis for an ellipse. Now consider the second data, considering point F from the directrix at a distance dmm. Now consider eccentricity less than 1 for an ellipse. That is the first required data to construct an ellipse using directrix and focus method. Later, an eccentricity given as 2 by 3, which is less than 1. So for this particular value of eccentricity as a given data, we have to divide OF, means the distance of a focus from directrix. That distance we have to divide into 2 plus 3 equal to 5 equal parts, right? Suppose eccentricity E is given as 3 by 4, which is also less than 1. In that case, you have to divide OF into 3 plus 4, that is equal to 7 equal parts. Okay? Divide OF into 7 equal parts. Suppose eccentricity is given as 2 by 5, then again divide OF into 2 plus 5 equal to 7 equal parts, right? I hope this point is clear, right? Value of eccentricity is given less than 1, right? So for this particular case where the eccentricity value is 2 by 3, we have to divide OF into 2 plus 3 equal to 5 equal parts. Now moving further, we have to divide this OF into 5 equal parts. So divide that distance, that is dmm, okay, and number all the points. Here you have to remember that 1, 2, 3, 4, the marking I have done from the focus F. Now draw a vertical line passing through the point 2, which will be the vertex V of an ellipse. Ellipse has two vertex points. So the first vertex point will be 2 over here, right? For this particular case. So point 2 will be the vertex point. From that, you have to draw a vertical line, right? Now, from next step, draw an arc from vertex V. So consider V as a center and radius equal to 2f. So this 2f you have to take radius, V as a vertex, draw an arc which intersect the vertical line at point P, which will intersect this vertical line which is passing through vertex V at point P. Now join the line OP. Now draw a line passing through point O and point P. This line, which is passing through the point O and point P, is called a scale line, as it has a slope of 2 by 3, that is equal to eccentricity. So this line is nothing but a scale line. Here you can see that we have considered V, that is the point 2, as a center and 2f as a radius. We have drawn the arc. So this vertical distance, that is Vp, is the 2 unit, while OV, which is the 3 unit. So the slope of this line is 2 by 3, that is y by x. Okay. So this line defines the slope, that is equal to eccentricity, which is the given required data to draw an ellipse. Now we will move further. After completing this, as I have already told you that ellipse has two vertex points. So one vertex point of an ellipse we have fixed at position of point 2. Now we have to find this second vertex point. So to find out the second vertex point, draw a line passing through the focus F at an angle 45 degree to the axis of an ellipse. So from F, draw a line at an angle 45 degree which will intersect the scale line at this particular point. Now project the intersection point of a line passing through focus, this line which is at 45 degree, and a scale line. So this intersection point we have to project on axis of an ellipse, and that will give you the second vertex point, that is V1. Okay. So after finding the V, that is the first vertex point, and second vertex point V1, now we will move further. So in the further step, mark at least 5 to 6 points on axis of an ellipse towards right side of vertex V. So in this particular direction, towards the right side of vertex V, we have to mark 5 to 6 points on axis. Here mention that not necessary at equal distance. Okay. Whatever points we will mark on this axis, it is not required to consider equal distance. So we will randomly mark 5 points, and of course we have to name all these points. So we are considering it as A, B, C, D and E. Now from all these points A, B, C, D, E, we have to draw vertical lines. These vertical lines will intersect the scale line. Name those points as A dash, B dash, C dash, D dash and E dash. Now what is the purpose of this procedure? Now when you consider, say, triangle O A A dash, right? If you consider this triangle, then as I already told you that this scale line is having the slope equal to eccentricity. So here A dash, okay, divided by OA, that slope will be 2 by 3, right? Similarly, if you consider OB dash, then B dash divided by OB, that will be 2 by 3. Okay. Same way E dash by OE, that will give you the slope that is equal to 2 by 3. So the purpose of this procedure is to locate the points in such a way that ratio of its distances from the focus to the distances from the directrix, that should remain constant, and that should be equal to slope of this line. Okay, that is equal to eccentricity, that is 2 by 3. Okay. So now we will see that how we will utilize this concept. Now in the further step, we will mark the different points. Those points will define the ellipse. So now draw arcs from the focus F of radius A dash. So first we will consider the radius A dash passing through a point A on both sides of the axis of an ellipse. So here we have to consider F as a center, A dash as a radius, and we have to draw arc on line passing through A, means on this vertical line on both the side. So that we will get the one point, that is P1 point on above axis and another P1 point below axis of an ellipse. So if you look at this point P1, which is at a distance A dash from the focus, and from the directrix its distance is OA. Okay, so that is equal to slope of the line, that is nothing but the 2 by 3. Now we will move further to obtain the different points by following the same procedure. That is, say for P2 we'll follow this procedure, focus F as a center and radius equal to B dash, this B dash as a radius, and we will draw arcs on the line passing through point B. So if you look at the point P2, okay, this 2 are the point P2. So if you look at the point P2, which is at a distance B dash from the focus, and from the directrix its distance will be OB, that is nothing but the slope of the line, that is 2 by 3. Right? Same way we can obtain point P3. For that, to obtain point P3 we will consider focus F and radius C dash, okay, and we will draw arc on line passing through point C. So we can obtain point P3. Again here from focus distance is C dash, and from directrix that distance is OC, that is nothing but the slope of line, that is 2 by 3. This distance is OC. Same way we can obtain another points P4. Okay, here we have to consider the radius D dash and arcs on the line passing through the point D. Similarly, we can obtain point P5 by considering the radius EE dash and center F. We can draw an arc on line passing through point E. So point P1, P2, P3, P4, P5 are obtained. Now as we know that ellipse is a closed curve, so that this curve should be closed and it should pass through the vertex V1, second vertex V1. So now in the next step, we will consider another point which is nearer to V1. So consider point F on the axis of an ellipse, and that is nearer to vertex V1. So consider F randomly, consider point F on the axis nearer to V1. Follow the same procedure, means draw a vertical line from point F. We will get the F dash on the scale line. Now consider focus F as a center, radius F dash, and draw arc on line passing through point F. This we will get point 6. Similarly, we can consider another point, that is point G, in between point F and V1, and we will follow the same procedure, means from point G draw a vertical line. On scale line we can get the G dash. Now F as a center, G dash as a radius, draw arcs on vertical line passing through point G, right? So we will get point P7. So now we have obtained all these points P1, P2, P3, P4. In between you can take, if you want, for the smoothness of the curve, if you want you can take different points in between E and F. Joining all these points P1, P2, P3, P4, P5, P6, P7, vertex V and vertex V1 in proper sequence with smooth curve, an ellipse will be obtained. So this is the procedure for the construction of an ellipse using Directrix and Focus method. Now we will see how to draw normal and tangent at any point S on ellipse for this particular method. Consider point S as per given data. The procedure to draw a normal and tangent at any given point on an ellipse for this particular method is common. So here we will consider the point S and we want to draw a normal and tangent at the point S. So as a first step, we have to draw a line from point S to F. So draw a line SF, then draw a line from focus point F that is perpendicular to SF. On directrix, we will get the intersection point that is the T. After getting point T, draw a line from point T through the given point S, which is nothing but a tangent at point S on ellipse. Okay? So this line will be a tangent at point S. Now, as we know that tangent and normal are perpendicular, so from S, we have to draw a line perpendicular to the line TT, that is nothing but the tangent. So that line will be the normal N, that is denoted as N. So this is the procedure to draw normal and tangent on a point on ellipse which is constructed using directrix and focus method.